let's go ahead and apply the method to the equation y double prime equals negative 6y. Okay, well, we let y equal a e to the kt, and of course y double prime will be k squared a e to the kt, and so forth. So we're going to, just as usual, get the equation y equals k squared a e to the kt equals negative 6 times a e to the kt. Dividing the a e to the kt, we get k squared equals negative 6, and this has two solutions. K equals plus or minus the square root of negative 6, which would be plus or minus the square root of 6 times the square root of negative 1, which is plus or minus square root of 6i, where I is the square root of negative 1, the basic imaginary number. So our solution is going to be simply, well, we're going to have a y1 of t equal a e to the plus square root of 6 I t, y2 equal, again using a different constant here, b e to the negative square root of 6 I t. And general solution, y of t equals a e to the square root of 6 I t plus b e to the negative square root of 6 I t. Now let's verify that at least y1 of t is a solution to the equation. So let's see, y1 of t, of course, is a e to the square root of 6 I t. So y1 prime of t would be, by the chain rule, square root of 6i times a e to the square root of 6it, and y1 double prime of t would then be, we get another square root of 6i from the chain rule. So we'd have the square root of 6i times the square root of 6i. The square root of 6 times, well, let's write it out. Square root of 6i times the square root of 6i a e to the square root of 6it. This is all very straightforward. Understanding what it means, well, we'll get to that in a minute. But square root of 6 times square root of 6 is is 6. I times I is negative 1, so we'll have a negative here. And then we have a e to the square root of 6it. So that if we I'm not sure the camera did what I expected it to do there, but let's continue and hope. Substituting this for y double prime and this for y clearly gives us negative 6a e to the square root of 6it on the left hand side, and negative 6 times a e to the square root of 6it on the right hand side. So we verify that y1 double prime of t equals negative 6 y1 of t, and that y1 is a solution to this equation. We also conclude that, well, we can also verify that this linear combination, y1 or y of t equal the y1 function plus the y2 function, is also a solution. We simply take the derivative, substitute into the equation, and we easily see that we have an identity.